All right, let's see if it starts the recording. There we go. Yay. All right. I'll even turn my camera off or camera on. This will be fun. So I have the new NVIDIA broadcast feature that's supposed to follow my eyes as I move to the left and to the right. So you can see it adjust. Can everyone else see it? You see it adjust?
It works.
So I occasionally have blue eyes, gray eyes, green eyes, brown eyes, just depending on the lighting when I start. And then if I turn it off, like it changes to the original color. It's kind of strange. All right, cool. And it has the head tracking. So this will be fun when you start presenting and I just point it at you. All right. So hopefully everyone can see the slides as well. Welcome to the Indy.net Consortium. We're back. Huh? Yeah. We're finally back in person. All the calories that we are going to get with free pizza. It's going to be awesome. So we're brought to you by Theoris. I think everyone else is not a sponsor anymore because, we're not meeting there anymore. But 1150 Academy, who sponsored us for years and probably still will, because John's still there. So we'll see. And then Oscode, I think they'll still give us free stuff. I just have to ask. We'll find out. And then Launch Fishers, which is where we used to meet, but now thank you, Theoris. Not only did they give us pizza, Pizza. We should give them applause for pizza and calories. And now an awesome space. I'm Ari Rahimzadeh. You can just call me Ari. I'm one of the organizers. I work at Klipsch. And very excited about tonight. We've got Matt Osbun presenting. Boop, boop. Yay, talking about stop reusing code. I'm very curious about that one. Them's fighting words from a platform guy. And I'm very excited about this presentation. We're working really hard to line the presentations up for you again. Probably bringing back the lightning talks and so forth, doing that again, maybe some more fishbowl conversations. That'll be a lot of fun, but also still speakers and doing things in person. So hard to do the lightning talks and the fishbowls when you're virtual. Learned about that. So if this is the attendance we're generally going to get, then that's going to make fishbowls and lightning talks a lot of fun. So very excited about that. I know, Nicole, you want to talk about jobs and anyone looking for a job. Yay, that was good. I thought you'd come up here, but yeah. Yeah. Oh, there we go. And we're hiring at Klipsch as well. I know I'm specifically looking for .NET backend developer, really just .NET. We do Xamarin, Maui, ASP.NET, and twice a week. And then I'm also looking for a firmware developer. So if you know anyone who is a firmware developer, please let me know. Yay. Was anyone here affected by layoffs, like with Salesforce or anything? Yeah, sorry. Oh, Geico. Yikes. Yeah, that was just announced. Okay, well, yeah. Great. So without further ado, Matt, and while you're walking up here, I'm just going to point out that we are part of the .NET Foundation. So it's a very cool thing. They also have the .NET Virtual User Group, which brings together user groups from around the globe. So you don't have to fly to Spain or Italy or whatever. That's why I didn't need to fly to Italy. Oh, I could have done it virtually. Teams has a purpose. Great. All right. It was funny. See, end with a joke. Cool. All right, Matt, it's up to you. And I'm going to move over here and then flip the camera somehow.
So, as mentioned a few times, I'm Matt Osbun. I am a solution architect with a company called Applied Information Sciences. We're a consulting firm for all things Azure. And I think I'm gonna open up. You see, I didn't know when I signed up for this, that this was gonna be the inaugural meeting after 3 years, so.
No pressure.
No pressure. Yeah, after I signed up. So I'm gonna start off with a little story that I'm just doing for speaker's prerogative and has nothing to do with what I'm going to talk about. Is anyone familiar with the experiment with the 5 monkeys in the ladder?
And the what?
Ladder.
No.
Maybe that one's finally fallen out of fashion. So, as it's told, there a group of psychological researchers got together a group of 5 monkeys, put them in a cage, put a ladder in, and at the top of the ladder was a bunch of bananas. And every time a monkey got up to the top of the ladder to get the bananas, they get blasted in the face with a fire hose. And after a little while, the monkeys stopped climbing the ladder because, well, obvious. Then they pulled one monkey out, put a new one in. Monkey tried to climb up the ladder. Everyone else pulled them back. No, don't do that. You get hit in the face with a water hose. And then they started pulling more monkeys out after a while until there were 5 monkeys who had never once been squirted in the face with a water hose, and not a single one of them would touch that ladder. So 2 big things to take away from this story. Number 1, this never happened. I actually tried to find the name of the person who did this. And after a bunch of research, this is just an apocryphal story. It comes out of a book written in '95 where the authors claimed that this happened, but offered no supporting evidence. Nobody caged a bunch of monkeys for the purpose of preventing them from eating. I feel that's important to point out. And number 2, of course, software development is a bunch of monkey business. So after that, let's start off with an easy one. Who here is dealing with trying to refactor or rebuild an application, a big application, and is having problems with it? How's it go? By the way, I'm not afraid to call on people if you don't want to talk. Both of my parents were teachers for many, many years. I will call on people if nobody's volunteering. So, Alex, how's it going?
Ow, it hurts. There's a lot of problems and it's not safe.
Ah, interesting point. It's not safe. Why is it not safe?
Our tests are not great. Some might even say they're not good.
So, since you brought that up, who is starting to get the idea that maybe, just maybe, all of these unit tests aren't quite providing the value for effort that they're supposed to? Safe space here, guys. Believe me, I'm not going to judge, and I have not yet begun to speak heresy on software development. Anybody?
People do test that does something exist? That's test coverage. And I wish we had test coverage.
But here's the fun thing about unit tests. It's a lot like insurance. You pile on as much of it as you can, and you try really, really hard to not think about the cost. And if it doesn't do you any good, you consider it a win. For reasons, I guess. Now the fun one. Anyone here heard of or uses clean architecture?
Heard of it?
All right. Care to give an elevator pitch? What is it?
Have different parts for different things. One module for cross-cutting concerns and whatnot, and no, it's to build it out. One layer on top of the other. I can't remember right now.
So
I haven't done it for minutes.
let me just start out. I don't actually hate clean architecture. In fact, it's close enough to the way I arrange my own code that the differences aren't worth quibbling over. However,
Sean says nothing is clean about it. Sorry, let me change the inflection. Nothing is clean about it.
yeah, I will agree with that. And the whole idea of taking your end tiers and just twisting them around until it's a onion layer. I'm not entirely sure what that adds to everything, but the big thing that I read about and hear about every time clean architecture comes up is that the whole purpose is to prevent dependencies and coupling. Now, I'm going to throw out an answer that you should all probably figure out that I see differently than most people, but what do you think? Cutting down on dependencies, cutting down on coupling, good thing, bad thing?
That's how much change you have coming.
That is true.
Sean says it depends.
Ah, the consultant's answer. It depends. Guaranteed to always be right.
We should have him write his hourly rate in the chat.
So we're going to start from here, from the idea of coupling. And to really dig into this, the first thing we need to know is, what is it? So would anyone care to brave a guess? What is coupling in software development?
It's when two classes depend on each other for getting something done.
Sure. There are a lot of different ways classes can depend on each other. But a somewhat deeper answer, a way that covers all of those different cases, is coupling answers the question, what can break when I change something? This is not a small question. There are a lot of different ways this can work. Terms that I actually only ran into fairly recently and have to write down because I still get them mixed up in my mind. Afferent and efferent coupling is a measure of direct dependencies. Afferent coupling, and you'll note I'm reading this because I do get them mixed up in my head. That is a measure of classes in other packages that depend on you. So DTOs. They don't really depend on anything, but lots of classes use them. They have very, very high afferent coupling. If they change, lots of other things can break. If other things change, they probably won't break so much. The reverse of that then is efferent coupling. And why they had to name them so close together, didn't I assume it's to confuse people like me? But that's just the opposite. It is a measure of classes in other packages that you depend on. So orchestrators, service manager classes, that sort of thing. If they change, the classes they depend on aren't really going to be affected. But any of those classes change, it's likely to break behavior. And those two are pretty much the ones, at least in my experience, that people tend to think of when we start talking about dependencies. There are others. Temporal coupling. This is a fun one. It simply means things happen in a sequence. One thing happens, then another thing happens. The problem with that is if the one thing doesn't happen right, then in all likelihood, the rest of the pipeline doesn't happen at all. If one thing misbehaves, everybody loses out for it. So if you have two things that are temporally coupled together, you have to start thinking of the question, what happens when the middle thing breaks? Or even worse, what happens if you've already saved a bunch of stuff to the database, something in the middle breaks, and nothing else is going to happen? Now you've got a problem. Platform coupling. Technically, it refers to protocols and return types. Here we're talking REST versus SOAP, XML versus JSON, et cetera, et cetera. But more interesting, at least to me, than that, is having to know where something is in your platform. When you refer to something by URL, you have a platform coupling to that thing. If that URL changes, you now need to change your code. Worse, if that URL changes, you have to hunt down all the places where it's used and change that and hope you find them all.
Control Shift F.
Exactly.
Pretty sharp.
Yeah, resharper.
Yeah.
So talk about a combo platter of this for a moment. I recently was on a project that got hit with pretty much all of this. It was a rewrite of a central service that pretty much everything in the enterprise used. And the reason for rewriting it was valid and a good idea. It needed to happen. The problem is they started realizing that over 115 services depended on this service. Afferent coupling, efferent coupling, temporal coupling, platform coupling, the whole combo platter. And they started asking themselves, well, no, they started asking me, how do we roll this out? I said, well, guys, you have a bit of a problem. You can take down the other service and cause 115 outages that have to be dealt with right now, or business stops, or you can piecemeal it out, change little bits and pieces here and there, let everyone go through a testing cycle to make sure it works, then change another piece, make sure that works for everybody, and you'll put the entire enterprise in a constant testing cycle for probably the next 3 years. Yeah. They did not like that piece of advice. Unfortunately, I did not have a better one for them, because what needed to happen should have happened 5 years ago when they first started. And don't do that. Once you're to that point, you're at the big rewrite where you have to tear it all down and rebuild it. The nicest estimates I've ever seen on that sort of work is about an 80% failure rate. If we have time, I'll at least touch on a few of the reasons why that happens. But once you find yourself in that situation, the only way out of it is through strict enterprise discipline. You've got to commit to it. If you do it halfway, you may as well have not bothered at all, or you can have not done this in the first place. And that's really what I want to talk about. Now, after all of those, you won't find these by Googling. I made them up myself. First time I'm really talking about them to anybody. So talk about it, make it catch on, make it a thing. There are two other kinds of coupling that I have observed in software development. One I'm calling appropriate coupling. So let's imagine a code package of some sort. It has no afferent coupling, no efferent coupling. It is not temporally coupled to anything. It is not dependent on any platform. What do you have?
Hello world. Actually, no.
Exactly. You have nothing. Even Cruft does something. So, and the reason I bring that up is coupling is not a bad thing. You need it. If you don't have it, your code doesn't do anything. What you need to do is understand what you should and should not be coupling together. Because just ending it, which is probably not the point of clean architecture, but what I keep hearing over and over and over again with clean architecture, get rid of the coupling. Well, you know, that doesn't work. That gives you a code base that doesn't do anything. The other of the two is what I've started calling potential coupling. And start off with, it's not really a kind of coupling. It's when you have two packages that don't actually have any dependencies on each other, but could in a change in your code base. So data manager that is not used by a given service class that could suddenly start getting used by it in a future change. And while that doesn't sound all that bad, it's actually caused a lot of pain and heartache.
James says outputting the answer is a side effect. Sorry, I don't have the chat up there. I can't have the chat and the people I might need to invite showing at the same time for some reason.
Technology. You
Ship
think
it.
we'd figured it out by now.
Yep. Time to ship it.
So before I go on, quick stop, any questions? Good, that means you're all not listening to me.
What?
Really how I prefer this sort of thing to go.
Decoupling.
So, brought up potential coupling for a reason. If any artifact, class, package, whatever, in your code base can be coupled to any other, then it becomes extremely important to understand that class's behavior outside of any other dependencies. You have to find a way of testing it with all other dependencies removed. And that way, and only that way, can you understand that your class operates in a consistent and predictable fashion. And in case I haven't made this painfully obvious enough, I am indeed talking about unit testing, where we try and remove everything and mock it out so that the only thing we're testing is the core behavior of a unit of code, whatever we're defining that as being.
There was another message. Oh, what's there?
Arguably, unit testing has solved this behavior, will be generous, has solved this problem.
Oh, yes.
But
The little thing in the corner.
the burden
Oh,
of unit testing is not small. Has anyone heard of the 25-50 rule with unit testing? It's really, really old. So if nobody has, not a problem. I encountered this almost 20 years ago at a conference. Unit testing was this new thing that nobody was doing, but everybody needed to be doing. And the claim was unit testing would add 25% to your development time and save 50% of your maintenance time. Yeah, that's what I said. So this is nonsense. First of all, how do you measure something? I mean, seriously, how do you measure something like that?
Well, depending on your hourly rate.
Get out stones and tea leaves.
That's about what it would take. You cannot make an accurate measurement of that. And cannot make an accurate measurement of that. There aren't any. 2550 was made up. It was actually made up to convince development managers to allow their teams to start unit testing. Now, I haven't done an exhaustive survey of all development managers out there, but at the time, precisely 0 of them that I knew about bought into this notion.
Oh, Rodrigo says there's too many consultants in here.
And I tend to agree with that one. However,
Oh.
There's another reason why this is nonsense.
It looks like it is still working though.
There is no maintenance phase in software development. There kind of was at the time. And we'll get into this a little bit more, but at the time, maintenance meant bug fixing, which was really, of course, just a euphemism for refixing the things we should have done right in the first time. I'm sorry, question in the back?
Yeah, sorry to interrupt, but the screen behind you says that I'm saying.
Oh, that's okay. We should probably just turn it off.
Oh, okay.
It's not affecting the recording or anything. It was Samsung disconnected. Good call though.
Somebody was saying something, so I'm like, wait a second, something's not right here.
We're talking about debugging.
Yeah.
So
Thank you.
Yeah,
maintenance today, and we're going to talk about this in a little bit, but it means something very, very different. It means continuing to evolve and refine a product. Not so much, I mean, obviously we still have to do bug fixing, but it's taken on a very new meaning, but that has locked us into a cycle where we write a unit test that's designed to pass. And then later on, because we have better testing than we did back then. I mean, now we often have QA teams. We often, not always, often have testers. We often have testing built into our cycle. Back then, Wild West, nothing. You threw it out there and hope nobody noticed if it didn't work right. But now we create these unit tests that are designed to pass. The functionality gets tested. Generally speaking, works. I like to think we're doing better than we were 2 decades ago. And then you need to refine the feature as part of your maintenance. And you change the unit test to now support the new thing. The unit test has given you nothing. That's not a blanket statement. And I want to be real clear on this. I'm not saying don't write unit tests yet.
Oh, and someone mentioned I sometimes use ChatGPT to test the code.
I don't even want to think about that. I'm just hoping I make it to retirement before ChatGPT replaces us all.
I just want to know if it tells them to ship it.
So this all assumes everything goes well. You know, there's a thing people do, drives me nuts, blaming the tool when people use the tool improperly. It's not really the hammer's fault if you use it to bash away at your foot. That's really user error there. But mandatory unit tests have caused some interesting deviations in behavior in software development. Because unit tests lead to unit test metrics, which everybody loves, despite the fact that they don't really tell us anything worthwhile.
Code coverage.
You can have 100% code coverage and be missing scenarios that you need to test. Now, if you have 0% code coverage, you are definitely missing scenarios that you need to test, but 100% doesn't mean, all it means is every line of code is somehow hit in a unit test somewhere. That doesn't really tell you as much as you might think it does. And even worse, it assumes that every line of code has an equal need to be tested. That may be true. It's a terrible assumption to make. And all of that tends to lead to the dreaded unit test that's just designed to pass. I don't always see them as bad as a unit test that just says assert true, although I have seen that. But what developers tend to do, because let's face it, we're an arrogant bunch. If we wrote it, it worked, right? I mean, what's this testing nonsense? I wrote it. Clearly it does what it's supposed to do. So I'm going to write a unit test.
It works on my machine.
Exactly. Look, I wrote it, right? What's your problem? So I'm going to do the bare minimum I can with a unit test to make sure that the darn thing passes in the deployment pipeline, which we also didn't have 20 years ago, so that I can just get on to the next thing I need to do. Now, again, I am not saying don't write unit tests yet. Right now, I just want to acknowledge unit tests come at a price. More importantly, unit tests were designed to solve problems that do still exist, but they came about in a very different time. At a time when we didn't integrate testing into our process. At a time when testing really meant letting the users use the application and seeing what the help desk had to say about it. Our world has changed. Our processes have changed. Our way of meeting this problem has not. In a bit, I'm going to make a very strong argument for doing so. However, if you're not convinced yet, let's talk about the effect this has had on how we model our code. So I'm going to go out on a limb and say, likely everyone here knows what dependency injection is. And I'm going to double or nothing on likely 90% plus of the people here use it routinely. All right. So who wants to be on the hot seat on this one? I mean, I can pick on Alex again, but at some point he's gonna start taking this personally.
I'm up for it. I deserve it.
All right, so when you use dependency injection, you, I'm assuming, inject interfaces through the constructor of a class, yes?
Yes.
Okay, so when you make these interfaces, do they ever have more than one implementation?
Very rarely.
Spitball here, 90%, 95% of the time.
5% of the time, it's just a single class with a decorator on it.
Uh-huh. Here's the thing. Probably not true. It's probably a second implementation in a unit test somewhere.
Counting mock as a second implementation.
Mm-hmm.
Okay, but
An implementation that does nothing is still an implementation.
Okay.
And that's the thing. When you really start digging into dependency injection, and those people who really love it, it always comes down to that's how we support unit testing. So first of all, that means you're architecting your code to support your testing processes, which seems backwards to me. Your tests should test your code. Your code shouldn't care. Worse, you are architecting your code you're architecting your code for tests and not to support a business process. The term business process is going to come up a fair amount through the rest of this. So,
Oh, sorry. Sean says you don't need the bloody interface for most of the time.
yeah, that is a somewhat rougher way of saying exactly what I'm trying to say. You don't need the interface. As a matter of fact,
If you want, you can use that remote and just kill the TV.
yeah, you'd think I could do that, couldn't you?
I think they'll both work. There you go.
All right, so a little bit about interfaces. In how they're used in Java and therefore C#, which is kind of Java light, really. The idea was to add functionality to a class in a strongly typed language that does not support multiple inheritance. So for instance, C++ doesn't really need interfaces. They support multiple inheritance, which is neither good nor bad. It's just painful in different ways. In a debate that raged up in a very small community a long time ago, when Adobe finally caved to pressure and put interfaces into Cold Fusion, which is not strongly typed, nor is it a compiled language, but it's really just a scripting language. A lot of people just looked at that and said, why? There's no need for it. But in Java and C#, in languages that are strongly typed and support single inheritance only, you need a way to attach different kinds of functionality, thus interfaces. They add behavior. So first of all, if your interface is named I followed by a noun, you are not really making an interface. You are making an abstract class. I get very strict about this with dev teams that I lead. If you make an interface, it starts with an I and it ends with an ABLE. It is something that is able to do a thing. If you show me an I car, I'm going to ask you why that isn't an abstract class, and then kick the pull request back and tell you to make it an abstract class. Tip number 2, if you only have one implementation for an interface in your actual business code base, you don't need an interface. You might need an interface later. We'll let tomorrow's worries worry tomorrow. I really hate developing on spec. Used to do it all the time. And you'd think it would only take 1 or 2 times getting burned by that before I learned. But, you know, sometimes I learned the really, really hard way. And at this point, if it isn't in a backlog somewhere, as far as I'm concerned, it doesn't exist. If we need an interface eventually, we'll deal with that eventually. If I only have one implementation of an interface and nothing else on the roadmap, it's not an interface anymore. It's just a class. For instance, data managers. If you're putting an interface on a data manager, Why? And specifically by data manager, I mean a class that interacts directly with the database. iCustomer data manager or something like that. Unless you actually are planning on having two implementations, something that I suppose possible, but I've never seen before, you don't need an interface. You just need a class, and that's okay. However, with dependency injection comes dependency injection managers, because we want to make it easy. And by easy, I mean painfully difficult. Because what these things really do, now the first dependency injection framework I ever used was Spring. And it's the only one I like because it's not easy. You have to specifically map out all of your dependencies. There's no behind the scenes magic going on this thing, which means it's very easy to tell what you mean when you say something. And it's not impossible with, like the .NET Core dependency injection framework. I'm not saying you can't do it. I am saying it's not terribly easy. And sometimes it's extremely difficult to tell what's actually getting injected into a class, which can be a very real problem. What happens if the actual implementation of that interface contains a call to an API somewhere? First of all, you now have a whole new class of errors that you have to worry about and may not know that you have to worry about. You have to worry about now what happens if that API just isn't responding today. If whatever mysterious force that controls HTTP just ain't working for you today. But even worse, you now have a different way of measuring your coupling. You have one more than what you knew about, and more beyond that if that external API depends on anything. You now go from +1 coupling to +n with no idea what n equals, and if you're particularly unlucky, no idea that n exists.
Oh, James says for an API, particularly on a web API, you want to give the client just an interface, not an abstract base class. Oh, I missed that one. Thank you.
What about not creating mocks at all? Sounds a lot easier to me.
Don't want to spin up the database when pushing the greedy limits that they will test the skill.
What if we just used inheritance and made those pesky methods that we don't need doing anything, not do anything? Now, this is actually a little annoyance with me and the C# language. That means you have to tag everything with virtual instead of Java, where everything is virtual unless you say don't do that, which I think is a far more civilized way of approaching inheritance, but they didn't ask me.
Sean says frequently devs are confusing the need to mock with the need, the need to mock with the need to implement an interface. Mocking can be done without interfaces.
Yes, it can. And unless you are dealing with an external resource that you do not want to change, and I don't necessarily count databases with that, but now we're really going down a rabbit hole. I tend to avoid using mocks and try using inheritance instead. There's a great video on this on YouTube. I assume he still has it up. Guy by the name of Shiv Kumar, SHIVKUMAR. Go look up his YouTube channel. I'm sure his video on unit testing without dependency injection is still up there. He will do a far better job of explaining it than I will. So what we're really talking about here, everything that we've been talking about up until now really has one effect. We are making code bases that are very difficult to maintain. Difficult to maintain because everything depends on each other, or everything might depend on each other, because we're using frameworks that obfuscate what's really going on, because we're using we're using interfaces that hide what's actually happening. So, Alex, you don't get to answer this one. Security, performance, maintenance. Anyone want to take a crack at putting them in order, most important to least important? Security, performance, maintainability. Yes. Nope. Yes.
It's all the same. Yeah. I would actually think maintenance first and then security and then performance.
Maintainability, maintainability, maintainability. If your code base is not maintainable, it cannot be secure. If your code base is not maintainable, it cannot be performant. It cannot be predictable. It cannot be anything except on accident. And I try really hard to not rely on accidents. If you cannot maintain your code base properly, it cannot do any of those other things it needs to do. And that's why we have so much trouble updating our code base. That's why we have so much trouble deploying new changes, because everything is so unmaintainable that, and I'm sure I'm not alone in this feeling, you get to deployment day and you're going, I don't know what's really going to happen here.
And Sean says the real price of a system is not to build it, but to run, grow, and maintain.
Oh, yes, it is. How long does a system last?
Maybe 30 years.
Until you decommission it.
Yeah.
Until
Until people are willing to spend the money to replace it.
Until every line of code has been removed, every piece of data has been removed and you've done something else. That is the lifetime of a system. That's why I try very hard. I'm still training myself on this one, but try very hard to not talk about applications, because that's not really what we're doing here. We're talking about software systems. These things have more than just an executable that's running somewhere. It's more than just a website that's running somewhere. We have a software system that mirrors and supports a business process. And as our business processes change, so must our systems. And that's really what causes our deployment impacts our deployments, right? We can't update this system because too much depends on it. I'm quite sure I'm not the only one who's heard that. We can't update this system because we don't really understand what it does or how it works. Again, I'm fairly certain I'm not the only person who's heard this. Or we only do updates infrequently to ease the testing burden, which never made sense to me, because the longer you go between releases, the more testing you have to do. And my absolute favorite one, deployment windows. Who's heard the adage, never deploy on Fridays? Come on. We're not going to get all the way through this today. This is a lot, but the end point of where we're starting here is you can kick off a deployment at 5 o'clock on Friday, go home, possibly get a message on your phone that says something's gone wrong, pull over to a gas station, do a quick rollback. This is, of course, assuming you still go into an office, or not, and everything's fine. It doesn't have to be that way, but it does the way we build code right now. This isn't a oddity that happens because DevOps teams like to feel important. Every DevOps team I've ever worked with would rather feel a lot less important than what they do. Unfortunately, it can't be that way with the way we're writing code right now. So I want to say sometime in the mid to late 90s-ish, a guy whose name I wrote down, but not on my presentation notes here, wrote a list of 8 fallacies of software development. And then a few years later, right around 2003, somebody tacked 3 more onto it. And it's this last one that is the crux of what I'm talking about here. Ted Neward, in about 2003, 2004, suggested as the 11th fallacy of enterprise software, business logic can and should be centralized. No, he wasn't saying that it can and should. He was saying it's a fallacy that business logic can and should be centralized. And I realized that I kind of did this whole presentation a little bit backwards. I didn't start with my premise. I got to my premise about halfway through. But if I start off right out the gate, stop centralizing software, the only people who are going to be left in the room are the guys stirring the tar and plucking the feathers. We need to go through a long, painful process to see just how bad this fallacy gets.
I should have tested it first.
So before I move on to a solution, stop for questions.
I feel like you're trying to describe a different version of testing than the original unit testing, which always has the one question of what exactly is you.
We're going to get there. So the reason I did this is to solve a problem, you need to understand the problem. And I like to think we understand the problem. But code reuse, code centralization has been pushed in software development since I was a software development back when dinosaurs roamed the internet. And the big question, the big answer for why we should do this, the thing that comes up every time I talk about it, is to make changes easier. So we know where to look to make a change. And to be fair, that's perfectly reasonable. If you don't know where to look to change your code base, then you can't do it. And we're back to the unmaintainability problem. You need to know how to change your code base, which means you need to know where to look in order to do so. Code sharing was a first attempt at doing this.
Oh, Sean says, I blame the dry principle, which was interpreted incorrectly.
Oh, was it so interpreted incorrectly?
Dry should apply when a pattern has emerged, not prematurely.
Yes. So this idea came about to solve a specific problem, one that actually doesn't exist today. Two problems, maybe. First one, servers or devices that simply did not have the resources to run large applications, therefore don't write large applications. That was a little bit of it. The bigger part, though, was way back when this first started becoming big, we didn't use source control. Yeah. Can you even imagine trying to run an enterprise software development team without source control?
Yeah,
Yeah.
yeah, not like
You've got pretty good imagination, or you have battle scars, one of the two.
battle stars. DBA.
I mean,
Oh,
you're
and Sean adds, relational databases have also contributed with the normalization. Rodrigo says, been there. And James says, but you should be able to see a pattern before you start writing code.
you often can. And that's where experience kicks in. And I like the bit about relational databases because the relational model was created by Doctors Boyce and Codd to, again, solve a specific problem. It is not the problem that the Gang of Four was trying to solve with object-oriented programming, which, by the way, is why trying to merge object-oriented programming and relational databases always sucks. Because they're solving completely different problems. And if you don't understand that, you're going to have a problem somewhere.
By the way, before you speak of like absence of source control and a piece of a pattern, mine only just started using it last year.
Like fresh out of college or something?
No.
Oh. Boy, I'm going to try real hard to forget that I just heard that. So back in the days when your source control was the file server on your production machine, you had to centralize things because you had no idea where anything was, not really. But today, we have a very interesting set of data that can help us find where to make a change. We have source control. Now, I'm again going to go out on a very dangerous limb here and assume that the vast majority of people listening to me right now use some flavor of Git.
Get
Want to?
pull in this country.
Sure.
Dash.
But Git, Subversion, pretty much all of the ones that I've encountered except for Perforce and Microsoft SourceSafe, so don't use those, support a very interesting piece of functionality, tagging. You can tag anything with anything, which means, well, let's back up a moment, because the example that I see all the time with this 11th fallacy is Twitter and their 40 character rule. And the idea being, where
140.
140?
140.
And now we know who in this room does not use Twitter. But where is this business logic enforced? On the UI? Probably should be. On the tier right behind the UI, definitely should be, because we know we can't trust the UI. How about at the database? That makes a lot of sense. Tell you a even more dire example of this. Insurance company I used to work for had a business rule, and by business rule, I mean US law, that said an insurance policy has an insured and at most one spouse. This business rule was enforced all throughout the stack, because if we broke that rule, or law, as one might call it, the US government was going to come shut us down, and everybody gets to lose, which worked perfectly well right up until this company became one of the finalists to become the national health insurance provider of the Maldives, which would have been more revenue than the rest of the business combined. For those of you who don't know, the official religion of the Maldives is Islam, and Islam allows polygamy. We eventually abandoned that contract because we could not safely implement this business logic. Story for another time, but the point is, we don't really centralize our business logic anyway. We just kind of pretend that we do. But what if, going back to our 140 character limit, what if every time we tagged something that dealt with the 140 character limit, we tagged it with that business process? That way, if we need to change that to say 180 characters, first of all, we know all the files that we need to look at. They're right there in source control, tagged for our ease of searching. We also know the history that's gone into all of that if we care to really dig into it. We have a rich source of data at our fingertips that tells us how to find things in our code base. And it is, in fact, our code base itself. So source control essentially is a map of your source code in much the same way that your backlog is a map of your business processes, and can, and in fact should be used as such. So, having said that, just take a moment and imagine what your code base would look like if every check-in, if every pull request, if everything was tagged with a business process that it supported.
I could have a code base at that point that don't trust the developers to get disciplined.
And even if they were, it would be chaos. There's a lot of tagging going on. So clearly, we need to look at something else, something more. This isn't a bad idea. It's just not the right idea. I mean, what level of granularity are we talking about here? Do you tag everything that has to do with the order process with order?
Is everybody gonna be consistent?
Oh, certainly not. No. We don't do consistency. So there's a step beyond that. And it's a concept that actually used to get a lot more talk than I've seen today. And it kind of tapered off at some point and sort of fell off the radar. But we're talking about code cohesion. The idea here, it's more of a scale. Over here, you have low cohesion. Over here, you have high cohesion. It's not like a light switch. It's more of a spectrum. If you have low cohesion, you have a great deal of coupling, great deal of potential coupling, and more importantly, a great deal of coupling across business concerns. If you have high cohesion, and here's where we're going back to one of the two types that I made up, you have an appropriate level of coupling. So what do I mean by that? When your classes support a given business process, and only that one business process, nothing else, and nothing other than that package supports that business process, you have an extremely high degree of cohesion. So for instance, let's take a theoretical customer service. And by that, I mean a service that supports customers. I probably should have come up with a better example of that. But if it just supports the creation and maintenance of customer profile information, you have a very highly cohesive service. Once you start muddying the waters and blurring the lines to something that just gets customer information for everybody who wants it, we are now lowering our cohesion. Yes?
Sean says, I think he's telling James this. You can, but it's not always obvious. So what, oh, okay. So he says you should be able to see a pattern before you start writing code. But then Sean says, well, you can, but it's not always obvious. Here's an example where people think there's a pattern, but there's none. User interface. You think the two screens are identical because they have 100% identical elements and behavior. And just when you're done with it, a new innocent field is added, throwing off the pattern. And then James responded, that's far too big of a pattern to consider merging off the bat until with a means of customization. But components of that, say a name field that auto uppercases each word, can be foreseen.
So let's talk about a type of order service I've seen many, many, many times. It takes a product ID and a customer ID, and it's gonna buy that, and it's going to facilitate the purchasing of that thing for that customer. It, of course, takes a couple of fake interfaces, a iCustomer data and an iProduct data, so that you can inject into data managers, one that gets customer information and one that gets product information, so that both of those can be used in ordering. And now you have extremely low cohesion in 3 different areas. You have a customer data manager that does way too much. It supports too many business processes in that it supports more than one. Same with your product, because products look different depending on who's talking about it. To an inventory manager, a corporate buyer, and a customer, the term product means somewhat different things, or at the very least has different things that you need to know about it. If you just have a data manager that's supporting everything you might need for a product, it's doing entirely too much, which now means you have 3 areas, customer, product, and order, where you need very detailed unit tests to make sure, hopefully, nothing goes awry. Which brings us back to this burden of creating unit tests that probably aren't going to tell us much, and are probably just going to be updated as we continue to refine our product. Or we could have an order service. And here's where we are unfortunately going to get somewhat past what I'm going to have time with today. But let's say your order service already knows who this customer is, already knows what this product is. It doesn't need to go beyond itself to place an order. And what I'm getting at here is called the actor pattern. I've read a bunch of different articles about the actor pattern online. I don't like any of them. I see the actor pattern as, it's an example I give many, many times, the all analog office. An office, it does a thing, it doesn't have computers, it has a phone system, but you only get to talk to one group, none of this conference call nonsense. When you have an analog office, let's say you're placing an order. Somebody calls a person who takes your order. They write down this order. That piece of paper with the customer's name, what they're ordered, what that product is, how much they're paying for it, gets handed to different people. It's definitely going to get handed to the inventory manager, otherwise they don't know to ship something. It's almost certainly going to get handed to finance so that they can collect a payment on it. Each one of them is getting a copy of the data of a person's name and address and probably a few other things. So from a very strict don't repeat yourself standpoint, we appear to be breaking a rule here, but we're really not. I love picking on addresses for this. An address can be a designation that the postal system has given for where a person lives. So if you want to get a hold of this person, you can use an address. An address can also mean a place where you're going to ship a thing, in which case you don't really care who lives there. All you need to do is know what string of characters to put on the to field of your label so you can get your package to where it's supposed to go. Same characters, same data, very, very different pieces of information. When you start using the actor pattern, you find it's okay to duplicate seemingly code, to duplicate seemingly data, because what you get is this very tight code base where nothing ever leaves the business process that it's designed to support. And this is very important because this gets us a couple of very interesting things. One of the biggest ones is, and here's where I'm going to say, stop writing unit tests, depending on what you call a unit test. Because now what you can do is write tests that tell you whether or not a piece of code supports your business process. And let's face it, that's what we care about, right?
Sean responded to James, I've exaggerated on purpose, saying that this is how most often folks decide to reuse. I also stopped blindly trusting what business folks say. No two business people will provide the same. So by default, I duplicate with a mental to-do and later revisit those to-dos and consolidate them if necessary. Or let those independent implementations different paths.
Because if you don't need to consolidate it, it was probably a bad idea to do so in the first place. So I don't know if you want to call these unit tests or not. I do know that somebody that I have that I work with, who I'm going to show this video to, hi Tom, is going to argue with me on this. That's fine. We want to call them unit tests. We want to call them some other kind of test. I don't really get hung up on the names of them. But if you have a highly cohesive code base, you can now focus on what's important. Does this piece of code support a business process correctly? And who cares about the rest of it as long as it's supporting the business process properly? And you can do this because you have taken away the ability to misuse that code package. You can no longer use it somewhere else. Now, how do we do this? The easiest way that I have found is to rethink your folders in your source code. Right now, we like to group our folders by what the class, by the type of class we're talking about. So we have view folders, and we have controller folders, and we have service folders and data manager folders, or perhaps we break them out into different libraries. This is very clean architecture-esque. And again, not bashing clean architecture. It's kind of how I do things anyway, but it asks the wrong question. And because it asks the wrong question, it will not get to the right answer. It asks the question, how do we control dependencies? But if we rethought our folders and had a order folder, a customer folder, a, I don't know, product folder, and everything needed to support that business process, view all the way down to the database was in that folder, you're kind of on the right path here. I hear this described a lot as thinking vertically instead of horizontally, which I can kind of see, but now we're trying to put a certain spatial awareness on the code base, and that gives me a little mental static. But the problem with this is you now have to agree code doesn't cross folders. And if you've got a small enough and tight enough team that agreement does it, great. I would be willing to bet the vast majority of us are not in that situation. And if you are, I somewhat envy you. The way I like to do it, these different business concerns get their own repo. Yes, that makes for a lot of repositories. I don't care. Now, sharing code inappropriately is impossible. If for some reason you need functionality in one repo and another one, message contracts are common for this, package them up in a NuGet package, because we all know you don't unit test the contents of a NuGet package. We all know this, right? So if that's the only way you can get functionality from one repo to another, you cannot share them incorrectly. Everything in the repo supports one business process. Everything in that repo has very high cohesion. Everything in that repo can be tested to determine whether or not it correctly supports its business process. And now when you need to change that the code for a changing business process, you have a new top level that you can go to other than tag. You have repo. Yes.
Sean says, now we're getting into the choose your size services.
Yes. And a lot of this has been deliberately left vague because anyone who tells you that there is a definite definition of business process that works in all places is wrong. I say business process because it's up to the organization to determine what that actually means. Same with a lot of other things. Service, for example.
I might need to plug that in soon.
It might be advantageous to slice things really, really narrow and not have an order repo, but have many, many order repos. Yes.
You have a USB-C power over there?
I do not.
Oh, okay.
So you're telling me I need to wrap it up?
No,
Got
I'll just see if I can find, I can just switch it over to this and keep recording.
So if you have that hard boundary that you cannot cross, the repository, you know where to look for code when it needs to be updated. It will be easier to find code in that repo because it will be much, much smaller than the all-in-one repository where you have every line of code that you've ever written. It will be easier to test. It will be easier for, well, pretty much everything. Now, that's pretty much what I had, except to first of all say, I'm going to try and get back here because there's a lot that comes after this. If you want a big takeaway here, do some research, high cohesion, actor model. These are very, very powerful techniques. that will get you to the point where you can, well, to put it a better way, where you don't have to wait until you have a whole bunch of updates in order to create a release because they're so dangerous to do. So you only want to do them once every now and again. You can continue to iterate faster and faster because it's safer. It's like a Formula One car. They can drive so fast because they're so darn safe to crash. So that having been said, that's what I've got. Any questions, comments, snide remarks, slings and arrows? What you got?
Manage all the different versions of these NuGet packages. You've got your various repositories that you got to talk to each other based on some domain object.
Carefully.
Right?
Well, first of all, NuGet, if used correctly, handles the versioning for you. So it's now up to the team that supports a repository to decide whether or not to update. And there are some interesting reasons for not doing so. I ran into a situation recently using Azure. Wow. Azure Functions. Oh, I am so very tired and people are going to mock me at work for forgetting this. But basically, I tried to update a whole bunch of NuGet packages, durable functions.
Oh, yeah.
And couldn't because one of the NuGet packages broke item potency. And the nice thing about Azure durable functions is if you do that, it will not compile anymore. So it was not the case that I did not update all the NuGet packages. It was a case of I fixed the problem and then updated all the NuGet packages. So there are some reasons for not doing that. You're not ready yet. You don't need that functionality yet. You're doing other things. It's now up to the repository that needs the NuGet package to decide whether or not an update is necessary. It's no longer up to the publishers of the package to decide that you get new functionality now. Yes.
Rodrigo says, great job. Sean says, thank you for covering this important topic. And prayer sign
Thank you to all of you.
or a hand sign. I don't know.
And as a dedicated intro, yes.
My question, is there any overused or underused software design patterns? I'm really like trying to learn those.
They're all overused.
Yeah.
Okay.
Everyone you ask will say theirs is the best.
So the thing about software, the thing about, and by design patterns, I'm going to just restrict myself to the Gang of Four patterns in the book, which by the way, I still consider relevant and still have on my desk or nearish my desk. But, and these guys will even tell you, you use these when you need them. You don't use them to use them. Decorator pattern. It's my favorite example for this. It breaks a lot of rules. And we're not going to take the time to go through this, but it inverts a lot of things. It can cause a lot of oddities and problems. But on the other hand, if you have the problem that it solves, then it's a great tool for solving that problem. If you have literally any other problem, you want to avoid it. Flyweight pattern, another great example of that. It does one thing very well, and if you don't need that one thing, you will drive yourself absolutely mad if you try and use it. I've been writing and or reviewing code for about 22 years. I have used the flyweight a total of one time ever. It's not super common, but if you have the problem that it solves, it's a great way of solving that problem. So yes, I would say literally every design pattern in that book is overused because we get into habits, and even worse, we get into standards, and even worse than standards, we get into best practices. For the record, a best practice is an answer to a problem you don't have. Because if you have a problem, you don't worry about best practices. You just answer the darn problem. Yes.
To say, kind of contributing to it from another field. I know someone who has very well been known in the research of specifying who's the best tool for the job. But that does not mean the best tool is the one you think is easiest.
It is true.
And the sheer number of times people say, I use this because I thought it was it was a great situation. That appears countless times.
Mm-hmm.
Best tool for the job means don't go with what you know, you go with what you know will be the best.
If anyone's worked a lathe, then you know that the best tool for a job is not always the easiest one. On the other hand, if you want to do wood turning, you kind of need one. Yes.
Sean says design patterns are like spirits in a liquor store. I get this one. Use what you need when you need. Don't use all of them all the time. I think good will come out of it. And then Nicole said, thank you all for joining. And kicked everyone out. Oh, wait, I misread that. It said, thank you all for joining. Hope to meet more of you in person in the future.
Well, thank you very much for having me.
Rodrigo says, I'll be using only rum forever.
I respect the decision. Thank you, everybody.
Great. Thank you all for coming. We'll be here next month. Take a look. What are we presenting on last month? I should have checked. Jay's presenting next month. Right there. Yeah, so looking forward to seeing you next month. More pizza, more conversation. Thanks. Be well, be safe. Yeah, likewise. I gotta stop the recording now.